over Q. So find Galois group. At first I draw the diagram. This is a group, and what is the Galois group? Galois group is Q is here. Q is the Q. I write Q. This is the fixed field. Hence this portion is fixed field, and here this field is root 2 plus root 2, and root 2 plus, and this is the number of automorphism. I have to find out number of automorphism. There is a point A, and I have to find out how many automorphisms I can get. So alpha square, let alpha equal to 2 plus 2, and alpha square equal to 2 plus root 2, and alpha square minus 2 is equal to root 2, belongs to sigma. It belongs to F. Okay, field is F. Our field is the field. Field is F. And sigma into root 2 plus root 2, sigma into root 2 plus root 2 is equal to root 2 minus, because root 2 by root over 2 plus root 2 equals to root 2 into root over 2 minus root 2 divided by root 2 plus root 2 equals to 2 minus. Now sigma root 2 equals to sigma alpha square minus 2 equals to sigma alpha whole square minus sigma 2 equals to sigma alpha whole square minus 2, as it is automorphism. So friends, sigma alpha square minus 2 minus alpha square minus 2, and sigma alpha equal to sigma alpha equal to root over 2 minus root over 2, and our polynomial is alpha to the power 4 minus 4 alpha square plus 2. So hence four equals to gal Q by. Find the intermediate fields of, this is the answer number 1, and second question is find the intermediate fields of Q cube root of 2 comma root 3 comma I and dash QI. So friends, Q root 3 comma I such that qi equals to 2 because the irreducible polynomial polynomial of root 3 over qi is x square minus 3 since root 3 does not belongs to q. Now cube root of 2 comma root 3 comma I such that q root 3 comma I equals to 3 because the irreducible polynomial of cube root of 2 over q 3 comma I is just cube minus 2. So hence q into cube root of 2 comma root 3 comma I such that q I into cube root of 2 comma root 3 comma I such that q root 3 comma I into q root 3 comma I such that equals to 3 into star 2 equals to 6. Now a qi is base 4 for q into cube root 2 comma root 3 comma I is 1 cube root of 2 into xi cube root of 2 xi square root 3 cube root of. So friends, we get the basis. We get the basis qi base for cube root 2 root 3 root comma I is 1 cube root of 2 xi cube root of 2 xi square root 3 and root 3 cube root of 2 xi. So friends, we get this is. And now I apply the fundamental theorem of Galois tells us that whatever this tells us that one 1 2 1 1 correspondence between sub 1 to 1 correspondence between subgroups of gal Ki and the intermediate fields between K and Qi, the intermediate fields K and Qi. Friends, here F is equals to Qi. I just show the diagram. This is the K, this is the 1-1 relationship E, F and Galois group and Qi that they fix. Let's the subgroup of gal K by Qi, the intermediate fields between K and Qi. Gal K divided by Qi isomorphic, as we see that order of whatever we see that order of gal Q comma root 3 comma I by Qi equals to 6, which is only group of order Z6 and S3. So it may be 6 automorphisms. We can get 6 automorphisms. So intermediate fields between K and Qi are Qi comma cube root of Q I comma Q I comma cube root of 2 xi and Q I of xi square. So friends, this is my intermediate field where xi is equal to minus half plus I. So friends, our next discussion is cyclotomic polynomial. Cyclotomic or cyclo. This is the cyclo I mark and tomic. So friends, what is the meaning of the cyclo? Cyclo means circle and tomic means cut. Tomic means cut. So you can see this is a circle. So this is a circle and it is cut into 8 parts. You see this is the number 1, 2, 3, 4, 5, 6, 7, 8. So friends, it is cut into 8 parts. So 8 root of unity are the root of x, and another factor that the radius is 1. Radius is 1. Circle radius is 1. So the 8 roots of unity are the root of x to the 8 x to the power x to 8 minus 1 equals to 0. It can be written this way. X to 8 can be written x minus 1 x plus 1 x square plus 1 and x to the power 4 plus 1. Obviously reducible. We can write it as well. It's now these factors are so called cyclotomic polynomials. So this is phi 1 x phi 2x phi 3x. This is this is phi 4x and this is phi 8x. Phi nx is polynomial with roots n, order exactly n. Now I can write this way: x to the power n minus 1 equals to summation d by n phi d n. It's short, the pretty obvious that the nth roots of 1 are of order exactly d for some d dividing n. D dividing n. This is just a product over d divides n. You can see recursively that this polynomial has integer coefficient. This polynomial has this coefficient, integer coefficient, and if you remember the Mobius inversion formula, coefficient integer Mobius inversion formula phi nx is equal to product of d by n x to the power d minus 1 mu n by d. Here n and phi nx roots. When n equals to 1, then phi nx equal to x minus 1 and roots is 1. N equals to 2, then it is x square plus x plus 1 and roots is minus 1. N equals to 3, x square plus x plus 1, where omega and omega bar is root. Omega equals to minus half plus I root 3 divided by 2. Number 4, x square plus 1, then roots are I comma minus I. Number 5, x to the power 4 plus x cube plus x square plus x plus 1, and number 6 is x square minus x plus 1. when n equals to 12, then x to the power 12 minus 1 is divided by x to the power 6 minus 1, x to the power 4 plus 1 into x square minus 1 equals to x to the power 4 minus x square plus 1. When n equals to 15, then x to the power 15 minus 1 divided by x to the power 5 minus 1 x to the power 4 minus 1 into x minus 1 equals to x to the power 8 minus x to the power 7 plus x to the power 5 minus x to the power 4 plus x cube minus x plus 1. So you see that the coefficient of the phi nx 0 and plus minus 1. Coefficient are 0 and plus minus 1. So coefficients seem to be 0 and plus minus 1. Fundamental property of phi nx. Fundamental property of phi nx. Phi nx is irreducible over Q when n is prime, then x tends to x plus 1, Eisenstein criteria. And n is prime power, then x is equal to at x plus 1 Eisenstein criteria. Eisenstein criteria also works, but what we want to do is to prove n composite, which takes a little bit. L, we are going to use Frobenius automorphism. We are going to use Frobenius automorphisms that we mentioned last lecture. So first of all, we notice the Galois group. Galois group phi bar n x contains z by n z star. Phi n of x is at least contained in the group of integer O prime to n under multiplications. Sigma zeta tends to zeta I. Galois extension and any automorphism must map sigma to must map zeta to the I and zeta to zeta to the j maps zeta to the I times j. So the Galois group is at least a subgroup of this. Want to the show Galois group is all of z by nz tends to order of sigma n equals to degree phi bar n x. If p does not divisible by n, phi n x is separable mod p. X to the power n minus 1, x to the power divides x to the power n minus 1 ddx, use ddx, then we get n into x to the power n minus 1 and x to the power n minus 1 comma n into x to the power n minus 1 equals to 1 if n does not equal 0. Factor phi nx mod p equals to phi 1 x, phi 2 x up to and Frobenius automorphism of f zeta. Frobenius. Friends, I will discuss very soon about Frobenius automorphisms. Another video, but you should know that Frobenius automorphism. Frobenius automorphism of phi zeta for each factor phi p zeta is zeta p modulus p. However, all roots of unity are distinct. Not p, we just showed this because the polynomial is separable. The polynomial is separable. So, phi p zeta phi p zeta equals to zeta to the power p in q zeta. We found an automorphism of q of zeta which raises each nth root of unity to its piece. So, Galois group contains is z by nz star multiplications contains p belongs to z by nz whenever and p does not divisible by n, and whenever p tends to this generate z by nz. So Galois group is the whole of z over nz. So phi nx is irreducible. I hope that I discuss some things, friends. However, cyclotomic polynomial is a large portion. I discuss very short. I discuss some such introductions. I need to discuss a lot of topics and also I will discuss Frobenius automorphisms. So friends, I hope that I can clear this concept. I hope that my all of friends can understand whatever I want to say. Thanks for watching.